Hey, my name is Daniel Granger. I'm one of the captains at UBC Baja, and I'm just going to start this video series to take you through our whole process from the start of the year, registration, to designing the new car, testing the old one, and then eventually be building everything. So we're going to be putting out these episodes every once in a while, and hopefully you enjoy them.
Like a Hellcat.
UBC Baja is an engineering student design competition where engineering students from across the world work together in their schools to design, build, and then race a single-seater off-road race car. So this is the one that we made last year, and this year we'll be building a completely brand new one, brand new suspension, geometry, frame design, and drivetrain. So we've got a lot of work ahead of us, and we want to take everyone along to see what we do. Hey, what's up, everybody? We're here at our registration competition. We got about 12 minutes left on the countdown. We're all up at like 5:30 today to get here in time, and everybody's super wide awake and super enthusiastic. We're registering for the Oregon competition because it's only a couple-hour drive away from us as opposed to the 30 hours last year. So hopefully we can click those buttons fast enough.
Everything. Well, if anyone has the button, just click it.
Woo! Kate's got it!
Should I add one too? Let's be number
Register
one.
now?
Yeah!
Yeah, let's just keep going.
So we managed to register successfully for Baja, Oregon 2018. So super stoked on that because it's closest one to home for us. And we were number 13, and the top 10 spots are given to the previous top 10 teams from last year. So that means we were literally the third person to click on that register button, and it's crazy because the events sell out in minutes. So stoked on that. Also, we got our weld porn order in, so we got a sweet hat. Really cool texture on there. That's not the main thing. Main thing is these cups from Furic. So this is their FUPA 12. So basically it's a big gas lens cup, diffusers in there, and that allows to have like a really long stick out, so you can get your tungsten in really tight spots without having to worry about running out of gas coverage. And the torch kit and some 2% thoriated tungstens for that, hopefully step our welding game up this year. So if anyone saw our Instagram stories from yesterday, they'll know our motor's in a little bit of rough shape. after who knows what happened. But so we just pulled it out today, but basically it was puking fuel out the air intake and oil out the exhaust. So we're gonna see what comes out.
I don't think much will happen. That's gas.
So that's what I thought. We had something flooding, and we got straight gas coming out the oil fill.
It is not supposed to happen.
That's like a full tank worth.
Can someone hold this oil can? It's going.
Oh, it's
That's not right. Confirmed incorrect.
confirmed incorrect. There we go. So we're gonna take a look at the carburetor and stuff and see if maybe the float in there's got messed up. But yeah, it'll be interesting to see. We've got a spare motor we can throw in for testing for short term if this one is
We have somewhere to do it.
in really rough shape. Another busy work day today. We threw the drivetrain back together, put the old engine in there, and CVT and stuff back on there because we're waiting on some parts to rebuild this one still. But we want to go out and go testing. So thankfully we've got a couple spare motors on standby thanks to Briggs & Stratton. But yeah, other than that, we've got lots of design stuff going on. We've got some hubs being modeled, FEA and analyzing them. So this here is a little mock-up of our new frame, just to get some physical dimensions and get a realistic sense of what it's going to feel like, because it is quite a bit smaller than the old one. So we started by setting a tape outline on the ground for the floor plane, and then we're using string and some plywood to just kind of put in the rest of the frame members, and so we can take a seat in there and see how it feels.
What's up, guys? We're just over at Industrial Laser Cutting. We just picked up our slab of metal, just a measly 400 pounds of laser cut steel. Gonna go home and jig up a table.
Yeah, so this is the jigging table we got from a new sponsor this year, Industrial Laser Cutting. They're based out in Richmond, and basically they've got a massive laser cutter, and we reached out to them, and they hooked us up with this table, and it's awesome quality finished cuts. Like I haven't done much with laser cutting before, but you can see there's like no kerf line, and the holes are super smooth. You can stick your bare fingers in there and you don't have to worry about getting cut up on sharp edges or anything. Really impressed with the cut quality. So we just started assembling our jigging table here, and everything slots together super nicely. Just one mistake. Damien, I just guess, forgot to include two of these cross panels in our order to the LaserJet guys, Industrial Laser Cutting. So they did everything we asked. It was our mistake for getting that. But so Damon's going to try and water jet two more out today so we can get this assembled. But it's awesome design. All these tabs and slots are just holding the whole thing together right now without any clamps or anything. and the fitment is really good, and that's, well, thanks to those guys at the laser cutting for you know, getting those tolerances and the offsets set properly. But we'll try and get everything pieced together and maybe start welding today. Okay, so we finally got all the pieces we need to put the jig table together. Huge thank you to ILC Industrial Laser Cutting. So we've got all the pieces here, all the little brackets and tabs, and a couple extra of the center supports that we forgot about, and we've got all the legs and all that. So it was our mistake, forgot to include that in the info we're sending them, but super stoked to have that now, and we can put that together today. Another project we've got on the go today is building a jump. So we've got the parking lot on campus booked for testing this Saturday, and all this wood. So here we'll build a couple jumps and do some testing. So we've got our mechatronics team this year putting together a data acquisition system. They've got all sorts of electronic goodies from DigiKey and wherever else, but basically this first version of our data acquisition system is going to consist of an accelerometer on each wheel and one roughly at the CG location, and we're going to go to the parking lot, hit the jump, do some other tests, impacts, jumps, drops, hidden curbs, whatnot, and basically measure the loads at the wheels, and then we can translate that data into our validation for our loading scenarios for doing all our FEA and analysis on all the suspension components and all that. So super exciting that that's come together, but it's going to get pretty busy in the shop later this afternoon because we're planning on putting together both the jig table and the jumps today. So I'm going to set up a time lapse and enjoy. Okay, so what we were doing there was getting the corner weights of the car, and so these are little scales that go under each wheel and give us the precise weight on each corner, and that lets us know about our front rear weight distribution, side to side, and all that stuff, and it can help us out with tuning stuff. And in this case, what we're going to be using that data for is calibrating our data acquisition system and accelerometers. So with that weight, we'll know with our accelerometers, they'll be measuring the acceleration, and we now know the mass, and from there we can calculate the force. Is that right?
Approximately.
So we're out at the test day. UBC is kind enough to let us shut down the entire parking lot for the day to set up our tests, and so we can see how the vehicle does. So right now we're setting up just a basic acceleration and braking test, 100-foot acceleration, and then we're gonna get to this point after the finish line, slam on the brakes, and we'll measure how long it takes to stop. And we're still waiting for our jumps to show up. Just gotta, here comes Adrian now. He'll be able to pick up the jumps, and then we'll get those set up and do some testing with our data acquisition system. Just got accelerometers mounted all over the car, and these are the mechatronics crew. Would you guys care to explain how the data acquisition system works?
Taking notes down. Basically, we have a system and it's taking input from our 5 accelerometers that are all calibrated, and we're just logging that to a CSV file. And then later we're gonna.
So you got this little box down under here, and that's where all the brains of the operation are.
Yeah, pretty much. And then we're gonna output it, put it into MATLAB, and get some actual loads. Should be fun.
Sweet. Yeah, that'll be a good time, because this way we can actually validate all our loading scenarios for suspension and stuff like that. So our jumps showed up. We fabbed these up with a bunch of wood just left around on campus, and so we've got 2 side by side, and we've got some adjustable height on there, and we're just gonna rear it up and jump off. So, Kate, does that look like optimal send it trajectory to you?
Oh yeah, for sure.
I got that one on camera.
Well, that's a wrap on testing. That jump was a little sketchy there, but I think we got some good data today. Good work from everyone helping out with all the cones and recording data, and only flipped it once.
I don't know why you look at me when you flip it. I didn't flip it.
That's a wrap.